Last Thursday, we started NIAF chapter 16. We got into graphs and digraphs, and mainly we were looking at these digraphs or graphs with directions. We talked about the vertices, which we've been calling nodes. We talked about edges, which are these directed arcs that connect them. And we went through and, we looked at a bunch of situations of how we could represent these. One was the adjacency matrix, where I took this representation and I put them all in matrices. And if I wanted to see two paths, I'd multiply those together. And we had conversation about that. And we also talked about this adjacency list representation, which was this whole idea of chaining again, where the first one represented A, it connected to the second, third, and fifth one, which were B. So, and here's the question, could I have made this a node and had a possible 5 pointers, because there's 5 locations coming out of this node? For example, it could have gone to itself and some different ways to represent it, but that's what we had talked about. All right, so today we're going to move on to the next section in this chapter, and we're going to take a look at, we had a list of operations, and one was, how am I going to go about traversing this? So I'm going to start by going back to a binary tree. As you can see, I have a representation here. It's different than what's down below, totally a whole new thing. But we're going to look at 2 different ways that we can traverse through a digraph, okay? The first one is called depth first search. So as we're learning about this, and I set this up, and I think of the depth first search, I think of a depth charge and how you would drop a depth charge off of a boat to try to blow up a submarine. And it starts and it just goes down, 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 comes back up and goes down, 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 goes back up and goes down, that kind of idea. So if I took a look at this and I'm doing a depth first search, I'm going to go to A, which is now going to go to B, which is now going to go to E, and I'm done. So now I go back to where I was a moment ago, the B. Can I go down any farther? Yes, I can go down to F. I can go down to H. Once I hit H, I start working my way back. F, can I go anywhere new? No E. B, can I go anywhere new? A, can I go anywhere new? So this time it becomes C. Then finally I start working my way back again. I hit D and I hit the E. Now the nice thing about thinking of it this way is I have a route and I know where to start. But if I come down to a little more complex type of graph and I say, okay, I want to do a depth first search, what's the result of the depth first search? Well, a moment ago, I just said, well, A was a great starting point because in a binary, but that's not necessarily true. I could have a search that says I goes to H and I'm done. Is that a good search? Well, the answer is no. Okay, it's not the best one. So I may be picking different starting locations. I know the one you all want to start at, and that would be A. So if I said, okay, you start at A and do a depth first search, what would you get? I'm going to start at A, and A is going to send me to, where's A send me to?
E.
E, good choice. Where else could I go to start?
D.
D, or I could even go to B. So I heard an E. Let's go to E first. I go from A to E to H, and at H I'm done. So I come back to E. Can I go anywhere else? No. I go back to A. Can I go anywhere else? Well, this time I can go to D. I can go to C. From C, I can go to B. Nope. So I come back to C. Nowhere else C can go. I come back to D. Up D can go to H. No, no, no. I keep working my way all the way back to A. The last place A can go is to B. And from B, I can go to F. So one of the things I have to remember is as I'm filling these, when I get to a certain one and I came back to A and I went to B, I don't list B again because I've already traversed and I found the B. From the B, I can go to G, which I have not been to. G goes to C, I've been there. B, I've been there. I backtrack to F. F goes to I, and I'm done. So if I start at I, the only place I can go is H. If I start at A, I can get to E, H, D, C, B, H, F, G, and I. I can get to all of those places. So once again, as I mentioned, the starting node we look at and see is A, but again, what if my starting node was G? I'm doing a depth first. I'm seeing as far as I can go. Where would you like to go from G? Well, I have two choices, right? Let's go to B. From B, I could go to F. From F, I could go to I. From I can go to H. Now, somehow in my world of coding, I'm thinking, oh boy, I don't know. Okay. H, no, back to I, no, back to F. F can go to G, but I already got G, but G can go to B. I have that. G can go to C, right? G can go to C. C can go to D. D can go to H. I already have that. I work my way back and I keep going all the way back to G and it looks like I'm done. 2, 4, 6, 7. So I got 7 out of the 2, 4, 6, 10. Never made it to A. Never made it to E. Where else didn't I make it? Oh, there are only 9. Uh-oh, I have 2 H's up here. Yeah, I don't like the depth first search as much. Okay. Again, this is called depth first search. Any questions?
So what would be the application of this?
So if you're at a node, say I'm at city A or I'm at city G and I'd say, I'd like to get to A, I could go through this search and say, oh, I can't get to A. Or I'm in here and say, oh, I'm at G, I'm starting at G and I want to get to E. I cannot get to E. Now the next one is going to be a little cleaner and clear and another way to do it. And I think it's more commonly used.
So it's basically just like a pathing algorithm.
Yep. Sounds like good terminology. Okay, so let's go to the next one. That was depth. This one is called breadth. Breadth. Oh, there it is. Breadth first search. All right, so the breadth first search is one that I like a little bit better. And we're going to see how this puppy plays out. All right, so this time, instead of going deep, I'm going wide. All right, so I'm going to start at A. This is just an explanation of how this works. You know, my arrows are pointing. It's a lot nicer than this. It's not as confusing. But let's start here. A can go to B. Agree? Where else can A go? A can go to C, and A can go to D. So now I'm done with A. I've exhausted everything with A. Next one I'm going to go to is B. B can go to E. B can go to F, right? I'm doing its breadth. Where all can just B go to? I'm done with B. C, where can it go? Nowhere. D, where can it go? To G. Good. E, where can it go? Nowhere. F, it can go to H and done. G, I come over here, it goes nowhere. And finally H. So it's almost looking like I go A, B, C, D, E, F, G, H. Just by the way it's laid out, I'm going row by row kind of deal to do this breadth search. But the concept I wanted you to get out of it is, where all does A go? Then I'm going to start after A. So all of these were one visit away. And then when I started the next round, where I checked B goes to, B went to E and F. These were 2 away from A. Wherever C goes would be 2 away from A. And wherever D goes would be 2 away from A. So now I'm going to start the next one, E. Wherever E goes to would be 3 away from A. Wherever F goes to, it's 3 away from A. And same with G, wherever it goes. So all of a sudden I say, well, I can go from A to H in 3 stops, A to B to F to H. So I want to keep that numbering concept in line or in mind. All right, I'm going to move down here. Breadth first search. Where would you like to start?
A.
I know you said A. I goes to H, I'm done. I don't want to start at I. Let's start at A. All right, so A goes to where?
E.
To B, and I know that's 1 stop away. A goes to
D.
D, that's 1 stop away.
E.
And A goes to E, that's 1 stop away. Okay, good. Now, where does B go? Because wherever B goes, it's going to be 2 stops away. B goes to just F, just F. So I know my starting city was A, and to get to F, I can get there in 2 moves. Wherever D goes, I can get to. I went to
H.
here. D goes to C and H, C and H. And finally, where does E go?
H.
H, but I already have H. Okay. Next one, F. Wherever F goes is going to be 3 away. Looks like F goes to I. Any place else? F goes to G. That's not in my list. And that's it for F. Does C go to anywhere that we haven't been to yet? C goes to D, already have been there. And C goes to B, I've already been there. Now I move to H. Does H go anywhere in particular? Nope. So I'm done with my 2s connecting to a 3rd city. All right, I, does I go? So wait a minute, there were how many? 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8. I could have stopped at that point because I did find all 9 locations. So as you start thinking about this from a programming aspect, you may have a counter that you can stop traversing because your while loop is while blah, 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 or num visited is not equal to 9 kind of deal. Okay. You like it? So you all see how I went through and did visits. So I can get from A to I in 3 stops. Looks like I'm going A to B to F to I. And that would in fact be, so another question I have is, can I get from A to B? Well, yeah, I can get to it right away. So from A, I can get to B in 1 move. Could I also get to B by going to D to C to B? Yeah, but it's not the drum roll. Drum roll says the shortest path. Shortest path. Okay, it's not the shortest path. All right, so let's just do another node we'll start at. Let's pick C. C looks pretty active. Where can C get to by way of shortest paths? So we've just developed an algorithm of how we're doing this. How we store this, I don't know. Probably in a two-dimensional array. How do we go from there? But the idea is, if I have these locations and, these are shipping routes. This is the only way I ship. It looks like I can get from A to everywhere. So that might be my main hub.
Could also do it in a linked list, I guess.
Possibly. Where you have multiple nodes come out, or excuse me, multiple pointers coming out.
Yeah.
I don't know. This is the part where the more you learn, the more dangerous you become as programmers.
You could also have a table of all possible paths with one node to of each node, but that takes a while. So
right. And one of the things we talked about this year was wasting memory, wasting compiler time, and all that. All right, I'm looking at C. C goes to B. Its shortest path is 1. Okay. C goes to D. Its shortest path is 1. And C doesn't go anywhere else. So where does B go? B goes to F. So I took care of that. B goes to F. So now the shortest path from C to F is 2. B doesn't go anywhere else. D goes to H. So its shortest path is going to be 2. And it goes back there. So that's nothing. So this shortest path is 2. F goes to I. So its path from C is going to be 3. And F goes to G. Its shortest path is going to be 3. And that's it for F. It only has 2 going out of it. H has nothing going out of it. I has 1 going out of it, which is H, and I've already taken care of that. G goes to B, which I'm okay with. G goes to C, which I'm okay with. So I'm done. So C can only get to the 2, 4, 6 nodes. C does not get to A, and C does not get to E. But you can start to see the shortest path from C to I. C to I is 3. It looks like 1 up to B, over to F, and back to I. Cool. And, in your book, you have the same kind of deal. It's written up a little bit differently, where from A to B, D, and E, it's each 1 path away. And then you start with the 2 paths, 2 paths, and 2 paths. And then you come down here. And for some reason, there's an error in the book. These guys should be 1 because it doesn't change. From C to E, you can get there in 1 move. Excuse me, from A to E. And right there it is. So that guy should have stayed a 1. Same way with H. That guy shouldn't, excuse me, from A to E in this column is still just a 1. So the book has a typo in it, which I'm glad to see. Questions? Okay. So as far as the shortest path is concerned, some of you have your program running. If I say from New York, I want to start in city 6, and I want to get to San Fran, which is city 2, what's it displaying? All right, I'm going to pick somebody. Share your screen. Who wants to share their screen? Who's going to have an 89.1% and really wish they had an A? Nobody sharing their screen?
Mine's not working.
Okay. Galen's off the hook.
Still trying to fix these syntax errors in mine too.
Okay. Matt's off the hook. When I said, do we need any more time? Everybody just sits there and they're quiet. Now we're finding out that quite a few people needed some more time.
For some reason, it just like it'll open the file, but it just doesn't do anything.
All right. Cassius has it. There you go. Start at city 6, which is New York. Destination city is San Fran 2. The shortest path is New York to Chicago to Denver to San Fran. Nice. Nice, Cassius. The second one was Chicago. Chicago's number was what, 4? Da-da-da. Chicago was 4. And I want to travel to Boston. So if I go from 4 to 5, which is Boston, I'm in Chicago and I want to get to Boston. I can't go that. It looks like I have to go to New Orleans. Let's see. Yep, New Orleans to Miami to Boston. Kind of pretty cool. Nice little arrows in there.
So with that, when you're setting up your text file, did you have to put numbers in front of these cities?
Cassius thinking. Do you want to show your data file? So we all know Cassius has an 89.1. And we keep saying his name today. Cassius, can you display your data file?
Oh, yeah, just a sec.
Thanks. It should have numbered them as they went in.
Mine will accept it. Like it'll open the file, but then just get stuck.
And that's what it should be. Are you putting the underscore under between Los Angeles for your spaces?
Yeah.
Okay.